Okay, everybody, here to talk about the solution to our little puzzle. If you haven't seen it, go watch the magnetism puzzle. So I want you to notice here that I've added something on. And you notice, if you can, that I've got these things to set up to where they barely intersect with each other. All right, so if this was a matter of flux, three things would be true. Number one, this would have to lose energy. They have to be losing energy from its system in order to sustain the statics here, because gravity is constantly working on these objects. Two, most of the, quote, flow of the magnetics would be coming out of the end of the bolt and going and looping back. So there shouldn't be the ability to have much remnant going into the screw. There shouldn't be enough to have just as much basically going into this bolt, this drill bit. Three, because of statics, the magnetic attractive forces between the screw and the bolt have to be equal. And consequently also there's going to be very similar forces, obviously different because of the vector angles, but very similar forces of attraction between the bit and the screw. So what does that tell us? That tells us that there must be some kind of phase state change happening. And now we're going to show you that we're right. Okay? So check this out. First I want to get this bit to behave here. The magnetic field is so strong at this screw that the bit is still being affected by it. I'm going to pull this apart. And look at that. Even out to here, it's still holding it. These are not magnetized bolts and screws. I haven't reshaped their structures. So when I disconnect, or at least take the sphere of influence of this magnet away from these guys, they fall. Now, there has to be some sort of phase state change. That doesn't mean that the actual crystals have realigned of this ferromagnetic. Look, it's not there. Right? They haven't been realigned. Okay, there's a little bit of attraction between these two. But it's not because they've been rubbed. It's because the atoms themselves have changed in their behavior. So now, if you have any thoughts about that, and how we can go about creating a better model, put them below. I mentioned before that there are other properties of electromagnetism that are essentially miraculous, that don't make sense, such as superconductivity, where you say that at this temperature everything acts normal, but then when it goes to just a slightly down here, now there is suddenly zero impedance, and magnets can just float over top of the ceramic. To me, that doesn't make a whole lot of sense in terms of classical theory. So we've got to come up with new and better models. If you have any thoughts, leave them below. Like, share, and subscribe, and I'll see you next time.